radicals, if you have to simplify a bunch of radicals, you got to follow the rules. So if you've got square root of 18 over y, first of all, see if you can simplify it. If you can simplify any fractions, and you can't because they got nothing in common. So you're going to rewrite it as the square root of 18 over the square root of y. And the rules are you got to pull as many squares out as you can. 18 has a square in there. If you look at 18, that's really 9 times a 2 and a 3 times a 3. So right there, that's coming out. That's going on the outside. 2 stays on the inside. So 3 is coming on the outside, 2 stays in, and then on bottom you got that. But you cannot leave a radical on the bottom. So you have got to multiply the top and the bottom by whatever this radical is. So square root of y, because you're going to create a square. So look on the top. You times the insides together, you times the outsides together. Outside is a 3. 3 times 1 equals 3. Insides times together. Y times 2 is 2y. Underneath, you've got a y times a y, which is a pair, which is a square, so it comes out. So your final answer, 3 times square root of 2y. On the bottom, you got y. You can have no radicals on the bottom. Okay, this one's just for the honors, so the regular kids don't worry about it. But if you've got 3 on top and then square root of 8 plus square root of 5 on the bottom, you're kind of in trouble because you've got 2 terms on the bottom and they're both radicals. The only way to change these into rational numbers is to multiply. You got to multiply by 1, but it's got to be a clever one. It's got to be the conjugate of square root of 8 plus square root of 5, which is the square root of 8 minus the square root of 5. So you got to times the bottom and the top by square root of 8 minus square root of 5. Okay, now this is awesome because on the bottom, when you start foiling, when you start distributing, square root of 8 times square root of 8 is just square root of 64, which is 8. And square root of 8 times a minus square root of 5 is a minus square root of 40. 5 times the square root of 8 is a positive square root of 40. Square root of 5 times a minus square root of 5 is a minus square root of 25. These two zero out, and that's 5, so it's really 8 minus 5. So cleverly, you change that bottom into a 3. Okay, now on your top, if you distribute the 3 to both of them, it's going to be 3 square roots of 8 minus 3 square roots of 5. And that is, oh, that's not it. Nope. Alright, here you gotta go one more step. You gotta simplify it because look, this, and this, they can all be simplified. You can divide everything by 3. So your final answer is just gonna be a square root of 8 minus a square root of 5. That's a good problem. Okay, the next problem, you've got to clean these out first because there's some squares in each of them. 32 is going to be 8 and 4. That's 2 and 2 and 2, and that's 2 and 2. So there's a square, there's a square. So that's coming out, that's coming out. There's already a 3 on the outside. So it's going to be 3 times a 2 times a 2, which is 12 on the outside. And on the inside, everything came out but this loner here. So he stays. Now 18. That's a 9 and a 2, and that's a 3 and a 3. So there's a pair. They come out times the negative 2. So it's going to be negative 6 square roots of 2. 54 is a 9 and a 6. That's a 3 and a 3. That's a 3 and a 2. So that comes out. So it's going to be 3 square roots of 6. Okay, now just like your tiles, just like the squares and rectangles and little squares, these tiles are the same shape. They are both the exact same shape, so you can add them together. They're like these guys. They're the same color, same shape, so you just count how many of them you've got. So Where am I? If I've got 12 of these tiles that are positive and 6 of these tiles that are negative, you're going to combine them and you're just going to have 6 square roots 2. And then what do we got? 3 square roots of 6. That is a totally different shape of tile, so you cannot combine them together. Your final answer's got to be that. I hope. I'm pretty sure. Let me look it over. Did we do it right? I think so. I think everything looks good. Because I probably will make a few mistakes here and there, so you guys got to catch me and tell me where I went wrong. Okay, this last one, multiplication, so let's times it. Let's times the 3 times the 5, that's a 15. 6 times the 2, that's a 12, but in 12, I know 12 is 6 and 2, and that's 3 and 2. So I need to take that out. Take a 2 out, times by the 15, 30 on the outside, 3 on the inside. And, okay, let's do some more. These ones are a little more complicated. Okay, these fractions, before you do anything, simplify what you can. 1 plays with the 5 and they're done. 2 plays with the 3, they're done. But 2 ways on top are going to cancel 2 ways on bottom. So I'm just going to be with a squared on bottom. Okay, so an a squared is a pair, they're going to come out. So on top I got square root of 2. On bottom I got 5a square root of 3. You cannot have a radical on the bottom, so you got to times this by 1. Because you times by 1 and you don't change it. But your 1 is going to be clever. It's going to be square root of 3 and square root of 3. So on top you're going to have square root of 6. On bottom you're going to have 5a. That's going to create a pair, so the 3 comes out. So it's going to be 15a. And that's it. That's as far as we can go. The 15 does not play with the 6 because the 6 is underneath and that's on the outside. Okay, multiplication problem. This, you got to distribute. It's kind of a distributive property. You need to multiply this guy by this guy. 5 times is the 5v, so it's going to be 25v times the square root of 5. But then when you times this, in front of here is 1, so 5 times is the 1, and that's 5. But your square roots times together, so that's going to be square root of 50v. And okay, inside of 50 there's a square, so that's 25 times 2. That's 5 and 5, so bring that pair out, times it to the 5 that's already out there. So 25v times square root of 5 plus 25 times the square root of what all's left under here. If you pull that 5 out, you just got 2v left under there. 2v. And these are not like terms. They're not the same tile, so you cannot add them. So I think that's it. You're done. 25v times square root of 5 plus. Yep, I think that looks good. Okay, this one, clean these up. 15 and 5 before you do anything. Let's clean them up as far as we can. That's going to make it easier. 15 and 5, divide them up by 5, so that's a 3 and a 1. Don't even really need to write the 1. Okay, on the insides, 3 and a 6. Change that to 1 and a 2. One of these x's is going to kill one of these x's, so it's going to be 3 x's on bottom. One of these y's kills one of these, so it's going to be y cubed on top. Okay, now x cubed is x, x, x. There's a pair. Same with y cubed. Y cubed is y, y, y. Take a y out, take an x out. So on top, you got 3y. Outside, on the inside, you got y. On the bottom, we got just x out. So on the inside, you still have 2x. Okay. You just can't leave a square root on the bottom. So times the bottom and the top by square root of 2x. So on top, in front of here, you're going to have a 1. So you're going to times your 3y to your 1, which is 3y. You're going to times your y to your 2x, which is just 2xy. On bottom, that's a pair, so it's coming out. 2x comes out, there's already x, so it's really 2xx, which is 2x squared on the outside. And that's it. Can't simplify anything else. Okay, change the 36 and 30, divide them both by 6. So that's going to change it to, divide them both by 6, that's a 6 and that's a 5. 2 of these x's kill 2 of these. 2 of these y's kill 2 of these, so that's 1y. So on top I've got just 1y. On bottom, can't remember how many x's I had. Oh, 2 x's kill 2 x's, so I'm left over with 2 x's, but that's a pair, so it comes out. So on top, you got square root of 6y. On bottom, you got x times square root of 5, times the bottom by square root of 5, times the top by square root of 5. So on top, you got 5 times 6, that's 30y. And on bottom, you got 5, that comes out, so it's going to be 5x. Okay, now, what else do we got? Okay, solving equations if they have a radical. You got to get the radical all by itself. Anything on the outside of it, you got to get rid of. So get rid of this plus 3, minus 3, minus 3, first move. So it's going to be square root of 3m plus 1 equals 4. Get rid of the radical. Square this side, square this side. So it's going to be 3m plus 1 equals 16, because that square undoes the square root. So minus 1, 3n equals 15, divide by 3, divide by 3, so n is equal to 5. Okay, now the next one I'm going to change it a little bit. Let's change that. Let's make this 16. Make it a 16 and then put like a 4 in front of here. We're going to make it a little more difficult. Okay, now you got to get v out by itself. You got to ditch the 8, you got to ditch the 3, you got to ditch the square root, you got to ditch the 4. So first, do everything outside of the square root. And you undo, add, and subtract first. So let's minus 8, minus 8. That is going to be 4 times the square root of v over 3 equals 8. Now ditch the 4. Divide 4, divide 4. So square root of v over 3 equals 2. Now you got to ditch the square root. So square that, square that. Square kills the square root, so it's v over 3 equals 4. Now ditch the 3. Instead of dividing by 3, undo the division. Times by 3, times by 3. You're going to have v is 12. The last one, there's nothing outside the radicals, so let's ditch the radicals. Square that, and it's going to ditch both of them. So then you just got 11 minus r equals 18 minus 2r. I'm going to get my r's on the left. So I'm going to plus 2r on this side, I'm going to plus 2r on this side. And then I'm going to get my numbers over here. I'm going to minus 11, so that's gone. Minus 1r plus 2r is 1r. 18 take away 11 is 7. And those are gone, so it's just r is 7. Okay, now looking at graphs of exponential functions. Okay, you look in the parentheses, and because it's 2 to the x, that means it's growing, it's doubling every time. Growth is either this guy or this guy. So growth looks like this. If it was decay, if it was like 1/2 to the x, that means it's shrinking by half every time. Then it starts big, but it gets small, 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 small. Okay, now, so it's growing, so it's one of these two. The plus 3 means that this asymptote is going to be up 3, so it's got to be D. So you shift it, you copy and paste it up 3, and this asymptote was copied and pasted down 3. Okay, 19. Alright, which one matches the graph? Okay, this one is decay, is shrinking. The asymptote is up at 6, so it's plus 6. So it's either this guy or it's this guy. And this is tripling every time, so it would be growing. This one's shrinking, so it's got to be that. And then the last page, write two exponential functions. One of them's got to be growth, one of them's got to be decay. But you got to use fractions for both. So your exponential function is like y equals something to the x. And anytime the a is greater than 1, that is growth. Anytime the a is, let's say it's less than 1, but it's greater than 0, then that means it's decay. So anything between 0 and 1 is decay. Okay, now let me go back here. So we should have done this. You've got to remember that if you have, if this was a negative 3, if you have a negative out here, it flips it upside down. So it's a growth, so it looks like this. The plus 3 moves it up 3. So 1, 2, 3, so it looks like this. But the negative would flip it upside down, so then it would look like this. It would just be flipped right over the, you kind of flip it over the x. Okay, now let's go back to, so anytime it's bigger than 1, it's growing. Anytime it's between 0 and 1, it's shrinking. So here we go. A growth bigger than 1 would be like 5/3, because 5/3 is really 1 2/3, which is greater than 1. So y equals 5/3 to the x. That's growth. Decay would be y equals 1/2 to the x. So it's bigger than 0, but it's smaller than 1. Decay, this one's growth. Alright, look at a function from a table. Here we go. How much did it change? 4 to a negative 2, that went down 6. Negative 2 to a negative 4, that went down just twice. But then negative 4 to a negative 2, that turns around and starts to go up twice. Then negative 2 to a 4, that goes up 6 times. So this is going to be quadratic, because that is increasing by 4, that is increasing by 4, that is increasing by 4. So it starts to shrink, turns around, and then starts to grow. It's going to be a parabola. It's quadratic because if I examine the change the second time around, it was always constant. Quadratic. This one is going to be exponential because it's growing by multiplication. It looks like it's tripling every time. If it grows by multiplication, so this one would be growth. So it would be 3 to the x because it's tripling every time. And then maybe plus or something out here. So that's going to be the foundation of it. So this one's going to be exponential. Linear, if it was linear, it would be plus 3, so it would be 2, plus 3 is 5, plus 3 is 8, plus 3 is 11. They grow slow, but they grow by plus or minus. And I think that's it. We are done.